gotta give it like a sec. Welcome back to this week's iteration of AI University. Today we are going to be focused on the core of AI agents. So that's a term that a lot of people say. It's AI agents. Really what that means is it is ChatGPT with the ability to use tools. Now, the general concept we're going to cover today is quite literally going to be the core of everything you work with moving forward when it comes to coding with AI agents. So it's good to have an understanding of how this works so you could start creating these reliable AI agent systems. I am streaming this on Twitch and on YouTube and on X. For those on those platforms, I'm actually hosting this live in the Discord if you guys want to ask questions. Small says he can't hear. I assume that you guys can, so just reconnect. So I'm going to move Discord to the side so we can start just getting right into it. But we're going to cover this. So first off, when it comes to what LLMs, ChatGPT, large language models, Claude has unlocked, I compare it to Pandora's box being opened up. So think only 2 years ago, before ChatGPT 3.5 Turbo came out, when it came to dealing with unstructured data in machines, like imagine giving them research or live data or analytics or all that, they couldn't do anything unless you hard coded it. You had to hard code algorithms to deal with your specific type of data. When it comes to LLMs now, you could just give it to them. You could just give them unstructured data. You could literally just give them a copy and paste of your spreadsheet of research data or market data or analytical data and whatever is going on, daily news data. Like, for example, if you give an AI agent that has access to your stocks the ability to check the news daily and, like, I don't know, give it access to that Bloomberg terminal, it would be able to make intelligent decisions automatically based on the context you give it. That was not possible 2 years ago. None of that was possible like 3 years ago. So it is I look at it as an infinite tool wrench, right? Like previously when we were building systems, you kind of would get stuck sometimes because it just something wasn't possible to do because the computer didn't have cognition. Computers now have cognition because of LLMs. By cognition, I mean the ability to receive data and act autonomously based on that data. I also see AI in general as a great equalizer where those who learn how to wield them gain superhuman efficiency that simply wasn't possible before. So everything we explore in this class moving forward is going to be concepts and skills and ideas that literally have not existed 3 years ago. I have been exploring all of this for the last 2 years, consolidating this info, still learning things. It's still new, but there's just so many opinions I see online and they're all wrong. So we're gonna start going into it. Now, in terms of the actual business opportunity, I try to explain to people. I'm always like, oh my God, yeah, there's a really great opportunity here. But people don't really understand by just saying it. So in terms of the number, these are the numbers. 10% of humanity, I didn't write the 10% here, but 10% of humanity use ChatGPT on a weekly basis. That means 10% of humanity have a basic exposure to AI. But that basic exposure to AI is chatbot shit. They talk like, oh my God, ChatGPT is my bestie. I talk to her about my homework. Kids using it to write essays or homeworks. Like, they're not really tapping into the full potential. Again, like, that's 90% of humanity that just doesn't have knowledge of this at all. Never used AI, never touched AI, don't even have an understanding of what AI is. So a majority of people on social media who talk about AI or talk about AI being bad or they don't know what they're talking about. Like they genuinely don't know what they're talking about. Now, when it comes to businesses in the United States alone that actually do use AI, there are 36 million small businesses in AI, and 76% of them don't use AI at all, don't have any exposure to AI, don't know what's possible with AI. So the business money-making opportunity of that, like someone in our general chat actually just said, like, hold on, let's pull this up real quick. Someone in our general chat literally just said, pretty sure I just landed a role as an AI consultant, got brought in to talk with them about branding and marketing work, left the conversation sharing with them how they can automate their proposal responses for the large transportation contracts. Brilliant, amazing. And see, that's kind of the opportunity that is presented here. Where the biggest problem that I am noticing, me personally, when it comes to AI and like getting people to hire you for AI, people just don't know what's possible. people don't know what's possible. People don't actually understand what's going on. Like, why would they hire you? You know, like, why would they even look into using AI? If you could show people, look how fast this makes me, I could make you that fast too, then it's gonna pique their interest, and then they're really gonna get into it. Give me one sec. I gotta open my. Okay, there you go. If you're on YouTube and Twitch, I can see chat now. Just FYI, if you guys got questions. But yeah, kind of point is people don't know what's possible with AI, especially because it's so new and advances so quick. So kind of your goal, right, as someone who wants to sell their AI expertise and sell their AI services is, hey, this is what's possible now. Look at what I could do. Look at how fast it could make you. And then they'll like really get into it and really want to explore it more. And then in terms of developers who know how to use AI, there's 47 million devs worldwide. About half of them at this point, like 67% of them use AI in terms of Cursor, or like use ChatGPT to help them. But really only 21% of them actually know how to code AI and build AI systems. And even less of them, and 15% of that 21% actually understand how to train models like from the base and do fine tuning and reinforcement learning. And my cat is fighting. Give me one sec. Sorry about that. Anyways, what I was saying is that there's very few devs in the world right now that actually know how to do system design with AI, and less of them actually know how to get into the depths of training a model and fine tuning a model, etc. That is all money. That is all a lot of money getting into it. So kind of I'm out of breath, bro. Out of chasing me. One sec. But the main thing I was saying is a lot of people are saying AI sucks, AI isn't reliable, AI isn't this, AI can't do that, all of that. It can. I know people who do government work that use LLMs to handle government contracts. That is something that you cannot fuck up. All right? And there are systems in place that they've made and they design that prevents that from getting messed up. That is like one example out of many. I talk to a lot of people. So the thing is, AI doesn't suck. AI could be reliable. LLMs could be reliable, and these systems could be reliable. The problem is that there aren't enough AI engineer and AI talent that could create these reliable systems. So the default exposure people get is that these systems suck and they're not reliable. Really, it's just a skill issue. So just keep that in mind. It's genuinely a skill issue. So in today's stack, we are going to set up the base of understanding how we could create kind of like the basic function calling in an app. I'm going to show you guys OpenRouter, which is my favorite. It allows us to use any model that exists in the OpenAI schema. And then we are going to set that up with OpenPipe. So one of the most important steps and the important core for making reliable AI systems is to be able to debug your AI system. On top of that, OpenPipe not only gives us the exact information we're looking for when we're working with AI agents or like LLM calls, but it also collects data for us. This is a very important part for building systems because over time, this training data we get is very, very valuable. It's gold, digital gold. So we want to make sure we have all that. And this is kind of just the core architecture we're working with. We're going to make like a basic chat app. I'm just going to vibe code this. I'm going to show you guys how I vibe code this and the wording we use, because it's less so about understanding like the perfect code to write, and it's more so understanding the concept and the foundation and the design and how these things work, so you could just write that in a prompt, and then Codex or Claude Code will be able to take your writing and like perfectly translate it to code, which is kind of the whole point of vibe coding. I try to explain to people. And we're gonna get into function calling in JSON docs. So this is how, kind of raw example of how AI agents or how LLMs output a function. So as a AI dev, this is you defining a function. In this example, literally what this is we are just giving the LLM a tool that allows them to get the weather. So we're defining the name of the function of the tool, which is get weather, and we're defining the description, which is get weather for a city. Now I want to emphasize this description part because we are feeding this information into an LLM. This description, right, This is part of the prompt. This is also a prompt. A lot of people don't understand when it comes to function calling, the description itself as well as the name is actually a prompt for the LLM itself. So this is how LLMs understand when to use the right tools when presented with the opportunity. And in terms of these parameters, these are keys that the AI will have access to that they will fill natively on demand. So in this case, we're giving the LLM, we're giving the tool getWeather a property called city. I know this is all looks confusing, so I'm just like explain the base. Like you really only understand it when you get into code, but just to understand like the utmost basics, we are giving this function one single key property called a city, and it's a string, and it's required. This is basically telling the LLM that, hey, when you use the getWeather tool, you have to tell me what city. You have to output what city we're getting the weather from. And then an example like this is the AI calls a tool, and then they call the getWeather, and then the LLM outputs that they want Austin. So in this example, if you're talking to this weather bot and you're like, hey, weather bot, what's the temperature like in Austin today? Then they would take that user prompt, which is what is the temperature out in Austin today? And it would internally think, how could I get the weather in Austin? Oh, I have a getWeather tool. I'm going to call the getWeather tool. I'm going to call the getWeather tool with the argument from Austin. And then in code, you would take the LLM response and then you would parse it and actually like use the LLM response to do functional things in the code, like save it to a database or execute an actual function because of it. And like that, this general concept I just explained, this is how every single MCP tool works. So that is like the raw skeletal core of how every MCP tool works. It is just define tool, LLM calls tool, you extract it and actually functionally call the arguments as if it were like a real function and a real input, because it is. You're just reading it from the LLM. So we are going to get into it and just kind of explain the code. I guess before I do, does anybody have questions in chat from like that general overview? Oh, someone is typing. Yes, I am recording this. Oh. Well, it's going to go on Twitch, which should be recorded. I forgot to hit personally start recording. What agent framework are you using? We're about to make one. The fuck? I don't use other people's frameworks. Ew. They're not reliable. So, this is also kind of the base on like how you can make your own agent framework, and just like, cause you don't want to just use an agent framework. Like it's cool to get the basics, but I personally just hit the AI. I just hit the API raw, because like I'm always doing something different in different like things. You don't really need an agent framework. Like it's all, I don't know. I just don't think you need an agent framework. So the first thing, assembly motherfucker. The first thing we're gonna do is learn OpenRouter. This is probably like the most useful AI tool. It's a unified interface for LLMs. So when we add this to code, I do hit the API raw. So we're gonna use this for code. And why I like OpenRouter so much is because it uses the OpenAI SDK for handling all of the code itself directly. And what's really nice about this is if you wanted to use any model in existence, you don't have to change any of your code. You could just simply change the model string into a different model. So we're going to take this basic setup and just run it real quick. So I had Codex make me. Yes. So I'm just having Codex set me up like a little TypeScript setup right now. I literally just prompted to make me a basic TypeScript app because I forgot the command to set it up. So I'll set it up. I thought this was gonna be done before the class, but going through OpenRouter. So in this case, if we have a model string right here and we wanted to change this to a different model that exists, like let's say a new model comes out or a new LLM comes out, you could literally just copy it. You could just copy the string and then replace it and boom, you don't got to change anything about your system structure. It literally stays exactly the same. I'm new here. Can you give me a brief explanation of what you do here? You're talking about here in the Discord or in general? I'm an AI consultant. I vibe code. I have like SaaS products I'm selling. I had projects and communities that I ran and automated running with AI. I've been doing AI every single day for the last like 2.5 years for 16 hours a day. What's the difference between Codex, Claude, Cursor? So I use Cursor, which is an IDE. This lets me visualize the code. And then Codex is a tool, is a CLI tool, so it's an agent in the terminal. That's kind of like the main difference. They both do code. It's just different kinds of code, I would say. So I'm opening up Cursor for this. I don't know if you guys use Cursor, but this is a one Cursor versus Codex. I use Codex in Cursor, so it's not a versus for me. So this is a fun little setup for you guys using Cursor. I like setting up my Cursor. I don't like my Cursor being set up like this, where there's like a terminal here, because then it squeezes it. So I actually like moving my terminal under the chat. So if you make a new terminal, you could grab this little, I don't know if my head is blocking, no, shouldn't be. You could grab the ZSH thing right here and drag it to the side, like that. And then I could grab chat and I could drag it on top. So now I have my chat and my terminal on the same little angle. So I could open new chats, and then I have the terminal here, and I have a lot more space right here. And it's kind of like my default setup for everything that goes on. No, I haven't had a chance to test out the Zyme thing, but I do. I want to make a video on that because a lot of people are asking how you vibe code for free. I didn't really think about that. Oh, and then finally, I'll just lock the group. So let me pray this runs real quick. Oh, okay, we didn't get embarrassed live on stream. Perfect. Okay, so I have the basic setup for my TypeScript app. So we're just kind of like going through. And what I'm gonna do is kind of just copy this base for, wait, what am I doing? Why am I manually coding, bro? Oh, this is embarrassing. I'm so sorry. So what I'm gonna do is I'm gonna copy the OpenRouter AI docs quick start, and then I'm gonna paste it into my Cursor agent right here so it could read the thing. And I'm gonna ask it to take my current TypeScript code base and create me a base AI core module that we can reference in the future using OpenRouter, and set up my .envs for it, please. So a lot of what I do when I'm just working with like docs and this basic code right here is, if there's a doc and there's a link, you can just copy it. Also, what's really nice is you could copy the page directly here, which I actually probably should have done out of convenience here. But for now, I'm gonna make a test.ts file so I could show you guys what this looks like. So on the side, I'm just kind of having it make me like a foundational code that we could work with. But I do want to show you guys this precisely. So we're gonna install the OpenAI SDK with OpenRouter. I think I could just OpenAI SDK npm install. Okay, npm I OpenAI. Okay, this is the run. Now we need an OpenRouter key. If you guys want to get your OpenRouter API key, log into OpenRouter. Go into your API keys, and I'm gonna make one for the class. I'm just call it September 10 class. I got scared with some of those npm packages since the recent npm hack. Well, first off, that hacker fumbled. First off, you didn't get anybody. Completely failed with the greatest hack of history. Completely failed, right? And then everything got wiped. To be safe from compromised npms, don't use npms. Just use specific versions. Like, don't have auto updating npms in if you're paranoid about like using different things. Docker plus virtual machines is a good one. For the most part, I mean, they handle the hack pretty safely. Anyways, I'm just putting a $10 credit limit. Research says using Codex within Cursor slows Cursor down. I'm confused, sir. Well, I don't really notice it. Okay, let's paste this in. So I am pasting this in for the sake of the screen. I don't think we need default headers. Actually, it would be good to showcase default headers. So let's say I have like my site, Butoshi.ai, and then this is Butoshi. So I'm gonna run this, and hopefully this runs off rip. So I could explain it. Cool, perfect. Okay. So just kind of going through this code real quick, because this is the basic code we're using with Open Router. All right, please don't steal my EMV key. I put a credit limit on it, so don't waste your time with it. I'm gonna delete it after stream. But just from the Open Router docs right here, all we're really doing is this is the basic OpenAI SDK schema. So the core of your LLM API calling is going to look like this. You have a main function where you have the completion. These are all like the basic OpenAI stuff going on. But this is the most important part right here. So you have the model, right? Where right now this is ChatGPT. You can see like above my head, this is the output. So, and then you have the messages role. So I don't know if there is an example of AI LLM messages array example somewhere. Is there? Yeah, so you got these three main. So you would have a system role, which is the initial instruction. This is the main thing you're kind of gonna be focused on when it comes to AI agents. And then you have user inputs, which is what the user or what the AI itself gets. And then you have the AI response, which is an assistant. So if I wanted to instruct this AI, I would already like fill that out. So if I wanted to make an instruction for this specific AI call, you could consider like this specific block and this line of code right here kind of the brain of the AI agents that you'll be working with. And this is what a lot of agent frameworks wrap. But in this case, if I wanted to explain like what the goal of this AI agent is, it's your goal is to simply explain what your model name is. And then as a user, pretend I'm prompting this in ChatGPT where I'm like, what is your model name? Or yeah. I guess what's your model name? What's your model name? Now in the side, if we ran this code again, you can see that my model name is GPT 4.0-Turbo. Now what's nice again about Open Router is even though this is following the OpenAI SDK, we could use any single model we want. So if I wanted to play with, like someone said GLM in chat. So if I wanted to play with Zai GLM and like see how that works, I could literally copy. I could go to Open Router models right here. I could copy the GLM. I could copy this, and I could switch the model to just GLM. Now, without even changing the architecture, because previously, without using Open Router, if you wanted to use different LLMs, they all have different structures. Like Google has its own structure, Anthropic has its own structure, and it's annoying as shit because you don't want to change your code just to use different models. So that's how you use Open Router, which centralizes everything into OpenAI. Now, if you run this again, you can see like the more detailed response of now we got the response output from GLM. And it's actually a reasoning model, so we get to see the reasoning in the output without changing any code. So this is the main reason why I use Open Router as a core for every API call I do. Just that ease of being able to switch model, change different models. It's very powerful. And a general design you want to do when it comes to making AI systems, like why it's important to have model switching is, look, I have witnessed so many startups get wiped out because of model upgrades. You don't want to build a product or build a system that OpenAI or Anthropic or Google could just release a base model and it wipes your business plan. Like it wipes your business structure. Like that's not how you make a sustainable business in like this new age of AI. The way you make a sustainable business or product in this new age of AI is if a new company releases a smarter model, it should amplify your existing product. It should not replace your existing product. It should amplify your existing product by a lot. And let's say I have this existing system design. Google comes out with a new model. Oh, cool. I would love to use Gemini 2.5 Pro in my app. It's perfect. Okay, boom, switch, paste, run. Now we're using Gemini 2.5 Pro in our app. So keep that basic right here. Keep that basic core where I need to build products or systems that do not get replaced when a new model comes out. I need to build products or systems that get amplified when smarter, faster, cheaper, more efficient models come out. Now, in terms of actually debugging, I'm going to show you guys this other app, which is called OpenPipe. And like I cannot live without this app. These are the two apps that I need in every single app, in every single thing that I do. Is OpenPipe allows you to, so they say they build reliable agents with RL. And this is like a more expert level thing you want to get into over time, which is also very good. So it's very important you guys start like learning this concept now before you even get into AI to get into this habit. Because again, your data and everything, your systems and your AI agents you make, every time they run, that is valuable training data. Again, remember when I said like this tech didn't exist 3 years ago? Well, this training data also didn't exist 3 years ago. So as people are making these reliable agents through very complex system prompts and system design and collecting all the training data, eventually that could get merged into a single AI model without like all this complicated systems. And then when it gets merged, then you could build systems around that base model. So it's something that's going to compound and improve, and like all of his data is literal gold. So get into the habit of capturing that gold. Now, when you log into OpenPipe, you'll be presented with this screen. And I have a lot of projects, as you can see. You can just make a project. So we're going to make a project for this class. We're going to call this 910 AI class. All right, and we're going to rename the project, create a new API key. Now, what's really nice about OpenPipe is check this out. So if we go to get started, and then we want to install the SDK, this is how nice this is how nice the OpenPipe SDK is. So in order to install OpenPipe, we do npm install OpenPipe. You know, this is like I'm focused on TypeScript. This works for Python. That's fine. So I'm going to install OpenPipe. Oh, critical severity vulnerabilities. We don't want that after that hack. Yeah, let's ignore that for now. Anyway, so you want to install OpenPipe. And then right here, where it says the import OpenAI from OpenPipe, you're literally just replacing the OpenAI call here with the one from OpenPipe, which is really nice. Now, if we wanted to add OpenPipe and start tracking that, it just goes into the OpenAI object and function we already have. So you could just copy this. You could paste this under like, I think default headers. Yeah. So you would paste it just in the same arrays under the OpenAI function. Sorry, same parameters. And then we want to copy the API key that we just made, or I guess make a new one. And then paste it in. So let me get rid of this line right here. So now this setup, what we got here is if I now run, did I break the install? npm install OpenPipe. Button test.ts. Did it fix it? Oh, thank God. Okay. Whew. So we just ran this. All right, we get the same response from OpenRouter, but check this out in OpenPipe. Now, if we go back to OpenPipe in the specific project that we ran, and we go to the request logs, you can see that call I just did now shows up in this request log. So every single LLM call that you're going to be cooking up is going to show up in this request log. And that's really valuable because you get to see what the system prompt is. All right, this is the exact system prompt we had. All right, here goes explain what the model name is. Boom, we got the system prompt. We got what the user said, or we got this. This is whatever goes into the message array. So this is really valuable for debugging if your message array is properly working, so you can see everything that goes on. So we get to see our user, and we get to see the outputs that the model gives us. Now this is surface level example, but if we go into the JSON, which is where we're going to be working for the most part, you get to see the more complex functions of what goes on. And what's nice here is like, look, you see in the text, it just says this output, but in the JSON, the response is much deeper than what the surface does. And this is just very valuable for one, again, debugging like the direct root of the AI agent work that's going on, as well as just seeing everything that goes on, which makes it really easy to correct your system prompt, correct your system design, your architecture, whatever else goes on, etc. So this is the core. Similar to tracing in LangChain, yes. It is similar to tracing in LangChain, except again, we're not using LangChain. We're hitting the API raw because we don't like agent frameworks. I don't like agent frameworks personally. You feel free to explore an agent framework, but I just think, yeah, raw is always better. So next, we're gonna go through. Now we're gonna we're gonna go into function calling now. So you guys now, I would say, and again, feel free to ask questions like anytime you guys are going through this. But the whole point of this initial setup is to show you guys the core of what this looks like. Now we can start building systems on top of this core. Now this prompt I did earlier. So I'm gonna go through here. I'm gonna let him do his thing. This prompt I set up earlier, where I'm like, take the current TypeScript core base and make a base AI core module that we could reference. The reason why I prompted it in this way is because, oh, where's this error at? Hold on, I gotta wait for him to be done. But what I do in every single one of my code bases is I like to have an AI utility folder that takes in the core. So to kind of walk you guys through like a more advanced one on what that looks like and one of the products I'm working on. By the way, quick side note, I'm working on this product called Daybloom. It allows you to create IP characters to life and put them on Twitter and social medias. So the way I work on that specific core function for Daybloom and how I have like reliable AI agents, and if you go to a character and you want to edit a character, I have access to all of these models. This is all OpenRouter and OpenPipe. So what's really important here is I have this core. So this is kind of like what my exact AI core looks like. So anytime I actually want to import or use an API function, I'm just importing like one single function, which is this, which is invoke LLM. And like this is my specific setup, which like we could get into later, but I'm just showing you like you're basically gonna copy, like once you make this once you make this folder structure once, you could practically copy and paste it into any folder, any structure you make. And so this gets kind of deep. So what I really like OpenRouter and OpenPipe for as well is you could add metadata on top of the LLM calls themselves. So for example, let me open this on a side tab real quick. So if I go to OpenPipe and I see my request logs, let me get like a, like here, for example. So this is this is from my dev run, somebody that is prompting. What's really nice is that you can add metadata. So when I look at these logs, I can see exactly where the prompt came from, which user it came from, all these different functions I have, like their organization, their run, whatever. I can see exactly what module that call comes from. So you could add these schemas on top of it as well, simply by just adding metadata to this. So if you go back, and then if I go back to This one. So this test.ts. I'm pretty sure I could add metadata like to the bottom right here. Does this work? Is that not where it goes? Let me search it up real quick. It would be OpenPipe docs metadata. No, that's not what I'm looking for. Oh, it would be in here. It would be under the completion. Oh, it would not be like this? Why is it tripping out? Oh. So you have to import. Oops, wrong one. Import OpenPipe, import OpenAI. Copy the completion. Oh, this is way different. I assume I could just run this. I don't know why it's bugging out. Let me test this. I think it's just a type thing. It's just not getting the type properly. But if I run this with metadata and then we go to our request log, go to JSON. Okay, cool. Yeah, I don't know why it's bugging in the code, but core example is, let's say that you're working with OpenRouter and OpenPipe and you got this whole setup and you want to add more detailed logging onto where specifically in the chain something came from. You would add a metadata key to the completion function right here, and you would be able to write literally anything you want. So it's like time, like I could add timestamp with a timestamp function, and like let's say I just want to see the timestamp. We could just run up the test. And then whatever you put for the metadata will show up into the OpenPipe call log. Like so. So this is really nice. It's really important to have metadata, and it's really nice to set this up in a way so you could log exactly where it comes from in apps you're working with. Now, what's extra nice about this is if you have metadata, then you could actually fill, like I have, for example, like 1,000 pages in one of my apps. I need to find exactly like a specific module broke, a specific LLM module broke in my app, and I got to figure out why. But I have 1,000 logs in my app. If you have metadata set up, you can see that it actually shows up right here in the request filter. So I could look for every single LLM function call that has metadata specifically. And then we could filter by this. So I think if I refresh. How do I filter by this? Refresh hard? Oh, I have to write in the timestamp it contains. 2025. Yeah, so you could filter by metadata, which is really nice as well. So very, very important feature to understand. Now, going back to this, usually the way I set up my core, again, is I kind of prompted that I wanted to have an AI core. And it seems like what the cursor agent did in here for us based on the docs is, yeah, kind of made us like this core schema. So I'm gonna go through with it and I'm just ask it to make me a simple, let me get rid of this. Let's give it our OpenRouter key from our example so that we could get into the function calling component of all of this. Okay, do we have a test file? Oh, we do have a test file it made for us. Okay. Button src index.ts. Ah, cool. Wait, did it work? Say hello from OpenRouter. Hello from OpenRouter. Oh, okay. Our demo does work that it's set up, so this is cool. So anytime, now that we have an AI core in our folder structure, anytime you want to call it in some module, I also have like logging set up. CC log, I have like a very specific way to do logging. Kind of autistic with it, but this is, I like Logger set up like this. Anyways, anytime I want to import chat or import an AI module into my app, into any function I'm working on, what's really nice is because we made it a default library function, we could just import it directly. So this is what Cursor Agent set up for us, is just a really easy centralized way to import chat anytime we want. And for chat to work, all we need is to set up the chat message. So the output now, like if I get rid of all these loggers, just to like really clean this up, so it looks nicer. Let me get rid of these loggers. Oh, we want that logger actually. Console.log reply. Get rid of this logger. So primary focus on this, primary focus on these two. We have chat messages, which you're always gonna want a system. That is what defines the AI agent in this case. You're always gonna want, whatever the user import is going to be the response. And then again, the response of the chat completion will be what the user logs. So why it's important to have a base like this is now that we have a central AI base, I could now, like, let's say we're working with Cursor. I can now make a new Cursor rule. So I would Shift Command P Cursor rule. I'll make a new Cursor rule, and I would call this AI rules, or just like I guess AI. Let's call it AI rules for now. And in this Cursor document, I would explain something like, well, I'm bad at explaining things, but fortunately, like the Cursor agent's good at explaining things. So I would go into the Cursor agent that just made this folder for me, and I would say to briefly, concisely write and explain how we can import and work with LLM calls in our code base following our structure. Now, what I'm doing here is because we successfully, right, and nicely set up an AI core that we could reference and import into any other feature of the app we make, we want to keep our design and our system structure very modular when we're working with AI agents. Because the more modular and separation of concerns that you have in your code base, it is so much easier for an agent like Codex or for an agent like Claude Code or Cursor to go into your code base and actually properly and reliably code up your code base. So by keeping this structure and then writing about the structure, so now we're going to write about the structure. We're going to make a Cursor rules that explains to every future AI agent, this is how you import AI calls into our code base. So we could begin really, actually vibe coding. So my vibe coding philosophy now is kind of changing, where if you set up your code base to vibe code, then you could just really fucking vibe code and just write whatever you want and not worry about it being wrong, because it's not going to be wrong. You set it up, so it's never going to be wrong. That's kind of how I code. So now that we set up this Cursor rules, everything here basically explains to any AI agent that works with our code base, hey, this is how we properly set up AI agents in our thing. So now what I want to do is I'm going to open up Codex actually. So I think Codex is nice. It's probably faster. Oh, there's a Codex upgrade. Hold up. Brew upgrade Codex. I don't even know the best basic steps to learn coding. You just got to do it. You just got to figure out how to set up the Node.js or Python environment, and you just got to do it. You just got to make something. Use AI to guide you every step of the way. You really just got to do it. It's the best way to learn. Do it raw. How do you overcome hallucination? By grounding it with actual data. So we could get into like this right now. But I'm going to prompt Codex. So specifically, I would start like Halima. I would start by having a goal that you want to solve, and figuring out like, oh, I want to create something. I want to create this, and then make it. So like have a North Star, which is something you want to make. It could be a website. It can make a tool. It could be an AI agent, and then start working back. I guess Just start figuring out how to get to your goal. As long as you have a North Star set, then you could use an AI system to help you find the journey and path in the middle, which is very important. Um, and in terms of how do you overcome hallucination, right here, especially when it comes to important apps, you overcome hallucination by feeding the LLMs with data. So by feeding the, like for example, let's say you're a food in like your food business or some sort of business and people have a lot of questions about your product. You beat hallucinations by giving the AI the answers it needs to answer the questions. And then there are certain prompt structures you could work and make where if the AI doesn't have specific information, it'll just straight up say, I don't know the answer to that, which is nice. So it's a mixture of a specific prompt structure as well as feeding the AI model context. So it has something to reference, it has something to ground itself. And if the information does not fall within that realm of context it has, then it defaults to I don't know. And that's like another system design to get into. But now, I hate when they go balls to the wall liar mode. Me too. It also depends on the model. GPT-5 is really good at not bullshitting. It's not perfect, but it's getting there. So now what I'm going to do in Codex, because we have this base set up, and I'm kind of just going to write this, I'm going to copy and paste these little docs I have for my code base. Write me in basic back and forth chat app. So I really liked the switch our model to, actually I'll finish this prompt. I'm gonna say using our AI core, write me a basic, can I see it from here? So I'm gonna say on top right here, write me a basic back and forth chat app using our AI core I can use to talk with an AI agent. I guess I can keep it simple for now, just so we can make sure we get the back and forth functionality working. Use simple React. Actually, I just want to talk to it in the terminal. Let's talk to it in the terminal. So I can talk with an AI agent in our terminal. When I run the command, when I run the app. So now Codex is gonna go in. Why Codex instead of Cursor now? That just felt like it. Specifically, so like actually, that's a great question. My thought process is I wanted to use Codex now because I had a good base set up and I had good rules set up and I want to create an entirely new feature. So because I want to create an entirely new feature, which is I want to talk and I want to prompt to an AI model, I could trust Codex to reliably use that. But really that thinking could also apply to the Cursor agent. But Cursor agents, I use Cursor agents specifically for one and dones. Like, I have a bug, let's fix this bug real quick. Or we want to like correct this one thing. When it comes to this like creating a whole new feature in a code base, that's when I go to Claude Code or Codex because their agent loop is really good and just continuing and just like running and running and running and running and running until, yeah, until it finishes the feature. Also, Codex is about to kind of go crazy with this one. What's he doing? Yeah, I have come to just like Codex a lot. Like, okay, for example, now while Codex is running, I have something else in my code base that I want to work with. And what I'm noticing with the AI core is that it doesn't import OpenPipe, right? Like we do here. So I'm going to take our AI core and I'm going to drag it into the Cursor agent. Okay, like, yeah, I'm literally going to drag it into the Cursor agent. And then I'm going to grab this test example that I made. There's like, we have this OpenPipe test example. And I'm going to prompt update our core AI library so that it imports and uses OpenPipe the exact same way we have in the test.ts file. Can you make a group of agents that do research, make the architecture code, and troubleshoot for you? I have that, but I kind of do it manually with the interface. So I use ChatGPT 5 Pro specifically. So usually when I'm doing like system design, I'll design it with ChatGPT 5 Pro or thinking mode. Or for like a cheaper, freer model that's equally as good, you could use Gemini 2.5 Pro and then have Gemini design the architecture. And then I take the architecture and I copy it and I paste it into a Codex agent. And then it just like rips the whole app. That's like the default I do. And I have a lot of videos where I cover that if you guys want to check that out. Also, look how fast. Okay, this is another reason. Codex is really fast. Like, that was really fast to just make something like that. And the cursor agent is just a little slow. I don't know why it's so fast. Maybe because it's OpenAI's thing, but it is really fast. And he's just kind of like yapping and thinking here. He's really taking his time with that. Anyways, so while he's coding that, we want to see. So there's a new CLI. If I run npm run chat dev, then I'll be able to talk with the agent in my terminal, it seems like. So now with that prompt. Ah, look at that. Wow. Okay, so now you can see we have terminal chat using OpenRouter. We're using the model this. We have a system prompt, and we have little help commands. Oh, cool. Okay, so can I just type if I just say hi? Oh, it does. It shows our logs, which I don't want. So I'm gonna prompt. So again, this is just like live coding example. Now I have like my interface that I could use and I could talk to the little model. What did I just say? Let's like play with it a bit. You just said hi. What did I say? So I'm basically testing if it has chat history. What was the first thing I said? First thing you said was, cool, so it has chat history. I'm gonna copy this, and then I'm gonna go to Codex real quick. Oh, that little ding meant that the OpenRouter client. Bro, what is he doing? Oh, I guess he is. Oh, I guess he's doing it properly. He is doing it properly. Properly enough. Anyways, so I'm gonna go through, and I don't like that it has like the logs here, so I'm gonna take this, I'm gonna copy this prompt, and I'm gonna just go back into Codex and I'm gonna just paste this. Be like, I don't like the loggers. Yeah, have a good day, bro. I don't like the loggers. Get rid of this for the terminal UI. And then now that we have our little terminal chat set up, I'm just prompting to get rid of the loggers here so we don't have this when we're running the terminal. I assume he knows what he's doing. So I'm gonna let them run. And then we could get into actual function calling, specifically how I prompt function calling. Because once you have this core set up, let me go back. Once you have this core set up, or it's really easy to just work and make these AI agents, and then you have good rules set up where AIs understand how to work with this. Like again, this is a one-shot prompt. Like I was able to make an AI chat app with a one-shot prompt because we set up the base. So very, very, very important key concept. So now if I run this dev, let me clear this up. And we undo the work that was done here. Oh, he's messing up the types here. I'm gonna undo these. All right, cool. We got rid of logging. You should make a video on how to vibe code for completely free. That is what I'm gonna do next. Now we're gonna get into, Now we're gonna get into function calling and how we deal with function calling based off like this tech stack right here. And I guess I'm gonna use Codex just because it was really fast. Now, what kind of tool do I want to make in the first place for a chat interface? If you DM me, yeah, that'd be sick. That'd be fantastic. Like maybe we could do something. Oh, okay. I have an idea of something we could do. We could give our terminal agent access to Perplexity so that it has access to internet search. So you can see like the live example of I'm going to ask it something, I want it to web search, and then I want it to give me the web search response. So we're going to get into the designing that loop real quick. So the 3 basic key ingredients I'm going to want right now is 1, I want the function calling docs open, because we're going to take all of this knowledge and we're going to prompt Codex with that because it does a really good job at doing that. Also real quick, before I do anything, I'm going to push this example code to GitHub. Get in it. Clear. Don't bring test.ts into here. So always push the Git. Very important. Very, 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 very important key thing. Anytime we make things, push the Git. So that's just one. Actually, I do want to point that out before I got into coding more with Codex. Is cursor is nice because you could kind of undo like that work I just did and it kind of messed it up. I was like, so I undid it. The thing with Codex, it don't got an undo button. It's just like Cloud Code and Codex, they've not got undo buttons. So if you want to undo your work, you can't. Unless you push to GitHub. And then you can undo it via the GitHub thing. So that's why like it's also very important to set these up. So you can also see the changes the AI does like easily in real time. I'm gonna assume that you're not gonna take my test.ts file because I need this as an example. I see to move this in node modules for now. Git add dot. Git add dot. Git remote add origin. Git branch main. Git commit in. Initial test. Git push. All right, now we have our base app saved on GitHub. Now I could move this back out. And then I'm gonna go back to Codex. Now that we have this nicely set up. And then I wonder if Codex, if I give Codex access to, because I do want OpenPipe to be a part of this app. So if I go to OpenPipe and we go to the OpenPipe docs, and we search up metadata specifically, updating metadata tags for node.js. So I don't want to update metadata tags on a request log after it's updated. I just want metadata. Tags like this. Oh, I guess it would be OpenAI metadata. Is it not in the OpenAI? Ah, okay. So we do have metadata set up right here. So I'm going to copy this example. Look at test.ts and upgrade my core AI functionality. Oh, real quick, so it's for people using agents, because I forgot to set this up as well. You could make an agents.md file. And in this agents.md file, I'm going to say always open up .cursor/rules and read everything in there. So I'm using cursor, I'm using Codex right now in the terminal. But only everything, if you have a cursor rules, it only uses the cursor rules from the cursor agent directly. And the way that Codex works, and I know this is confusing, bear with me. The way that Codex works, similar to Claude, is if you have an agents.md file, this is where you could prompt the agent with all the info you want of your code base. So anytime I'm working, well, every time because this is how I work, but every time I have Codex and I'm working in cursor at the same time, I have all my cursor rules set up, I will prompt the agent to always open up cursor rules to read everything in there. So I don't have to reprompt the agents directly, but I could just have one source that it'll always reference, that it'll always work with. It's either docs or cursor rules. So now if we go in Codex, I'm going to say update my src/AI core to have metadata so we can to have OpenPipe set up. Update my src AI core to have OpenPipe set up, similar to my test.ts.root. It's very important to have OpenPipe. Just taking the simple OpenPipe header and putting it in the OpenAI call with the key. So I'm going to prompt this to get OpenPipe set up via Codex, and I'm pretty sure it'll be faster than the cursor agent. And then in the meantime, we're going to start setting up the baselines we need to get Codex to prompt us working functions and to work with working functions. So first, we got our function calling SDK docs. Let me link this in chat as well. Where's Gucci? He says you look like Johnny to Tsunami. Wait, who is Johnny Tsunami? Someone in Twitch chat just said I look like Johnny Tsunami. Okay. That's funny. So we got our function calling. I'm doing good, Stargo. We're gonna get our function calling docs right here. I just put it in the Discord chat so you guys could look through it. And oh, they updated it. Oh, that's nice, actually. This is really nice. So they updated it as of the last week, because this is very different than what I usually work with. Anyways, you could read through this for a deeper understanding. What's most important is that the codex, is that the agent you're working with has a deeper understanding of this. Now, in my case, I want to, for example, give my terminal agent that we just made access to the internet via Perplexity. Now, what's cool about Perplexity is Perplexity has an API, or we could do something with Exo websites as well. We're going to stick to Perplexity for now, just to get something simple. And we have a quick start guide where we could just, we don't got to install it, we just hit the API and fetch it. So this is cool. So I want to get an API key. Oh, it's making me do all this complicated shit right now. Give me one sec. Perplexity, web search functions. Let me see. I'm trying to hot think what other tools we could probably use as well. Why is it asking me? I had my API set up. Oh, okay, here we go. Agents. So this is for today's class. I'm gonna say 9:10. So I'm not showing Perplexity right now because they do a really bad job at like not showing API keys. Oh, they show API keys now. Or they don't show API keys now. Okay. So I'm on Perplexity. I was just on the wrong tab. And I'm just gonna create my API key right now. Let's call this 910 uni class delete me before I get cucked in credits. I guess I can't call it that. Class delete me. Okay. So I'm gonna copy this, prepare this API key. We have our function calling set up. Back to the Perplexity docs. Is it seems like in the Perplexity docs, and I haven't worked with this in a minute, so bear with me, but the process is the same. Is when we make a Perplexity API call, you're literally prompting. So we're about to have a multi-agent loop where Perplexity is actually prompting another LLM agent to get us the responses. So we're going to create a function that allows our terminal agent to prompt another AI agent to get the result and give it back to us. Now it's nice that we have all of these docs here and we have working examples because the more context we could get, the better the Codex agent or the better the AI agent we're working with is going to function and is going to work. Oh, you know what? Hold up. I could show it off with basic. Before we get, oh, these are all good. Yes, thank you, Cypher. Thank you. My goat. Before we even get into the Perplexity thing, I want to show you just like basic tool calls with like a calculator. Because a lot of people, let me run this real quick. Let's make sure that what did Codex just say? Codex just said, oh, no errors. You updated the AI core to include the open pipe headers. So if I go and we prompt, do we have open pipe set up? So I can show you guys open pipe tools first. Give me 1 sec. So if I say hi, I forgot to import my open pipe key. So let's get our open pipe key in project settings, create new API key, create key, copy, and go back into our env, grab our open pipe key, like this. And now let's run it. Ah, beautiful. Okay. So we got our terminal agent set up with this. Now, a lot of people trip out on LLMs. Cool, we're set up right here. A lot of people trip out on LLMs because they say they can't do math. So just give them a calculator tool, bro. So we're gonna code up a basic calculator tool so you guys can see the process. And by code up, I mean specifically I'm gonna vibe code this because I'm gonna take the docs and I'm gonna give it to Codex and it's gonna know how to make a calculator tool and read the response for us just by reading the docs. And then I'll go through the code and I'll explain how everything works. Well, I'm gonna just copy this whole page real quick. Again, important practice. We just made a very important, kind of simple change where we have open pipe set up here now. Oh, we also have the chat terminal and open pipe set up here now. So I'm going to add all this to git commit m, added open pipe to core. Just so we have all of this nicely set. Now with Codex, I'm just going to open up a new Codex because I don't really need the same one. I'm going to copy this function calling page. And I'm just kind of pasting in the whole thing. I'm just really stuffing it in there, which I think it should do fine. How big is this? Let me read this context-wise real quick. So 10K tokens, that's nothing. That's fine. You can handle 10K tokens. So I just grab. So usually you just copy and paste it. I just grab the whole thing. I just grab the whole docs. And what's nice is this function calling, right? This whole docs also explains to the AI agent you're giving it to how it works as well. So now if I prompt, I want our terminal agents to, what's the word I'm looking for? To have access to a calculator tool. Now this is important because this is kind of the system design that we want to focus on. And this is how it always works. When you're creating function calls in LLMs, this is going to be the typical pattern you're always going to deal with. Is first you have, let me full screen this. LLM calls function. I guess LLM calls tool. Make this a box. LLM uses function. I'll call it tool. LLM uses tool. All right. And then the LLM parses the tool. LLM fills out the arguments of the tool. Actually outputs. LLM outputs the arguments of a tool. So in this case that we're about to work with, I want to use a calculator. So LLM uses tool. LLM outputs the arguments of the tool. Your app, like this, be straight. Your app reads the output of the LLM and executes the tool. Right, so LLM calls the calculator with whatever numbers it wants to multiply. Then your app reads the output of the LLM and executes the tool functionality encode. Functionality encode. Now let's say that you want to prompt the AI agent, and this is where we kind of get into agent loops and how agent loops work. Now the output, right? The output of your app function goes back into the AI agents. The output of your app function goes back into the AI agent, and then you kind of just prompt the AI to respond to the user with the new context. So this is the basic workflow that you're always dealing with, and it does go in a loop where anytime the user's talking to the LLM and the LLM wants to use a tool, the LLM will output the arguments of a tool, and it's up to your app, it's up to your system to read the output that the LLM just gave us, extract the parameters that I've shown you guys earlier in class to execute the tool functionality in code, and then the output of that function, whether in our case it's a calculator, whether it was Perplexity, and it is the response of the web search API, etc. That output, that context, goes back into the AI, goes back into the LLM, and you could reprompt the AI to talk to the user. And because the AI has context it gained from the function call of your app, it could prompt the user with correct data. So that's kind of like the core workflow we're working with when it comes to working with function calling in tools. So I want our terminal agent to have access to a calculator tool. It is just simple addition / multiply / divide / subtract with parameters of inputting numbers, 2 sets of numbers. So I just want to keep this simple for now to showcase the functions. Finally, I'm going to prompt it with, in the terminal UI, once you read, in the terminal AI UI, if the agent chooses to prompt, chooses to use the calculator tool, we read and execute the functionality. Take the output of the calculation and feed it back into the LLM model as a string. Take the output of calculation and feed it back into the LLM model as a string via a user array. Example. So I'm gonna write this out and then I'm gonna explain it, so bear with me because this is like my pro tips when I'm coding with AI agents. Example. The output is output. Use this to respond to the user you are talking now with. That way, the assistant can respond to the user in the same chat history. That way, the assistant can respond to the user in the same chat history with the proper context. of the tool it just used. Important to have the tool usage saved in chat history so it doesn't keep spamming tool. Okay. I'm too lazy to read AI news. Can you make an agent to make podcasts of it? I'm too lazy to make an AI agent that could read podcasts of it. Can you take my AI news and make an agent that makes podcasts of it? Please and thank you. You could also use Notebook LM. I love Notebook LM. So we're gonna go through with this. We're gonna wait. Also, see right here, real quick. So I'll read that out right now, but real quick, see how it reads the AI rules. I don't know, am I blocking that? See how it reads the AI rules, the Codex agent, and then it's starting to like prompt and do everything. That's why it's important to have that set up. Hello, YouTube chat. What's up? Okay, now to explain kind of the prompt I used right here is did it not? Okay, I can't find what I wrote, but to explain what I wrote to the agent, I basically instructed this exact design where I said, I want the LLM to, like, I want you to read the output of the argument that the LLM did. I want us to read and execute the calculator functionality. I want to output that response back into the AI agent, and I want to prompt the AI to respond to the user with new context. Now, specifically, the most important part about this process is when it comes to the message history array, which is kind of what I showed you guys earlier, like this specific combo of our chat message history array where you have assistant and then you have user and you have assistant and you have user. Let's say an assistant right here, and I'll show you guys, but like what's 1000 times 3? And then the assistant is going to decide to use a calculator tool. It's going to use a calculator tool. We're going to execute the calculator tool functionality and feed that context back in. When we feed that context back in, we're feeding it as a user array. We're feeding it back in as a user array so that we're kind of re-prompting the AI agent with the correct functionality. So again, bear with me. We're going to wait for Codex to finish. It seems like Codex has finished. Wow. Add a calculator tool plus executor. Did it? Oh, it did. Okay, let's see if the code worked first, and then we could get into this, and then we could just like really start ripping things. Terminal. Let's run npm chat dev. What tools do you have access to? First, I'm gonna see, can it see the tools it has access to? Wow, okay, so see, you can already see the AI agent, just because we coded this, already has access to the calculator tool. Now, if I say some crazy thing like, what's this number times this number? All right, like LLMs can't do this basic functionality, so I'm hoping that it can. Okay, let's see this. We got error to get response. Let's debug this and see what is wrong. And actually add logging back. Add logging back so we can see what's wrong. Actually, first, so again, we ran into a debug error. We ran into an issue right here where we just straight up got failed to get response. This is perfect. The reason why we set up OpenPipe is so we could see why we failed to get a response. And this is beautiful. So you can see that it did try working. It did try using the calculator tool and actually like using the operation multiply. We could see that it executed the tool and the output and it's trying to go back. But then we ran into an issue. So the issue wasn't actually in the tool call loop. The issue here is that an assistant message with tool calls must be followed by tool messages responding to each tool call ID. I have no idea what that means, but I'm gonna copy that. And so actually, so what's important here is copying this full thing. I want to copy, because again, context is everything. I want to copy the context of, hey, look at our pipeline, look at how it worked here, and how well it did. And then we got this error, and see if it could fix that. So I asked it to multiply and got this issue. So before it does any code, let me move this more up. Before it does any code, let me make myself smaller. Okay, before it does any code, I want to debug and work with Codex first. I asked it to multiply and got this issue. All right, so I'm going to paste in the input. The input worked. So I'm going to display the input worked, it multiplied, and we fed in the response. But when it tried replying again, we got this issue. What I'm going to prompt is, without coding, can you explain what the issue is first to me? So anytime I'm working with Codex, I really like having it explain kind of what change it might do if I'm debugging. So I can kind of overlook the change and correct it if I need to. But it's also a good reasoning step before it does a bug fix. So let me move myself to left side. And then our focus is right here, right now. But going through OpenPipe, this first call worked. So when I said what tools do you have access to, it knows that it has access to these tools. And then when we asked it, right, like what's this crazy number times this crazy number, it was able to understand, okay, I'm gonna use the calculator tool. He asked us times, so I'm gonna multiply, and I'm gonna use the first number and the second number. And then our code did successfully go in, right, and import as a user role, hey, you executed calculator, the output is result. Use this to respond to the user you're talking now with. And then we got an error where something at the end of the pipeline bugged and it couldn't talk to us. So that's now what Codex is trying to fix. Codex says the issue is the message ordering for chat completions. The assistant returned an assistant message with tool calls per the chat completions. When you sent instead, you appended a user message right after the assistant's tool calls and did not include tool messages. Azure rejected this because the fixed conception after the assistant's tool call messages, add a role tool message for each call with content and tool call ID from the assistant tool calls. Then make the next assistant. If you still want you executed trace for history, add it after the tool messages. Is that correct? All right, let's see if it, because you have context about the functions here, right? Oh, it does. Okay, please fix for me. It seems like he knows what he's talking about. From a brief glance, I would say that he potentially knows what he's talking about. This is a smart model at the end of the day. So we're gonna get this fixed. Now, in terms of the actual code, this is a base of what it looks like. So again, remember, the description here, I'm not sure if you can see it, the description here, I don't know, it's long, but this itself is a prompt, right? The AI knows what tools to use because it knows this prompt. First off, the name, it knows that the name is calculator. It knows it has access to a calculator tool, right? And then the description is how to use a calculator tool. It's very important to be very precise with this, especially as you feed more tools into a single AI agent. And additionally, you don't want AI agents to have a lot of tools because it could get kind of bad. So did he, whoa. Okay, it says that it should have worked and that it should run. So let's test this again. So if I run chat dev and I say, what's 88 times 3, 4? 88 times 34. Oh, that was quick. Damn, that was a quick loop. That was a really quick agent loop. Did it use a tool? Wait. We either got trolled or it just worked that fast. No. No, it just dead ass worked that fast. Oh, I guess, wait. Tool result isn't it right? So I guess we don't need this user part right here because it shows like the result of the tool usage after. But I like having this so we could define it more. Damn, that was instant, bro. I didn't think it was going to be that fast. Respectfully to my own code. Damn. Yeah, so you can kind of see it. So they took like 2 calls right here. So first we prompted, right? What's 888 times 34? And then it knew to use a calculator, 888 times 34. And then it instantly fed, like our system fed in the result, as well as you executed this. The output is this, use this to respond to the user. And we get this. So now from a user perspective of the interface, the AI is using the tools. We don't see that it's using the tools, but it uses the response of the tool to ground its result, which is how we could reduce hallucination from this. Okay, now let's say I want to add something. So, okay, that was the basics, right? Let's like pause real quick. That was the basics of defining a tool, in this case, a calculator tool, and then creating functionality that runs the calculator tool. And now anytime, so if we go through the code, so I don't know if you guys realized it as we were kind of like coding this from like the scratch or the ground up, but what Codex did here, especially like creating this executors for our chat thing, what Codex did here for us was practically make its own agent framework. Like that is what you guys are looking at right now. Like just from our prompts and like from working from that ground level from the start of class, like we've made our own agent framework. Now if I were to prompt, right, and again, this is what we're gonna do here. We have tested successfully how to make an agent loop system. And because of our nice structure, look, we even have like a nice tools on the set. If you want to define a tools, it literally, we have a calculator tool. We defined a tool here with the output, and then we define a function that takes the array and takes the parameters of the calculator tool to execute it. Now in our chat, anytime we have any tools, we could just give our AI agent access to the tools by making it. And because of the workflow we currently have, any tool we make in the future is going to instantly just go into the agent. So this is really cool. This was a neat little thing to just have. So again, I'm going to save this. So I like the changes. I'm going to push to GitHub. Right? Got agent loop and calculator tool working. Get push. All right, now let's say that I want to very quickly now make a perplexity tool using this. I want my agent to not only have access to a calculator, but to also be able to research and do stuff with perplexity. So taking the perplexity API cookbook, where are the perplexity examples we could use? Perplexity API. I guess it would be quick start. And this shows the array and the raw response. Oh, perfect. Oh, that's so beautiful, isn't it? They have a markdown. Guess what I could do with the markdown? I could copy the markdown. Now I could go back to Codex and be like, this works great. I push to GitHub. Can you make a tool that uses the perplexity API, update our .env example for this? Can you make a tool, this is kind of what I'm probably on the side, that uses the perplexity API That is a tool called Internet Search, which takes in a query and allows our main terminal agent to have access to the internet to respond to the user. And then I'm gonna paste in the Perplexity copy paste I just had. Now, very quickly, it should work very quickly from the experience we just had of taking the documentation that we have here and going back to, taking the documentation, taking our function calling tool that's already set. So I don't need those docs anymore because we already have working tools and working examples in our own code base. And then I'm gonna just need my Perplexity key after. So we will go back and just give it a sec. It's so nice. It just made its own framework for us. That's so beautiful. All right, and this is what the Perplexity tool looks like. So it's internet search tool, internet search. So the description is to perform a web search using Perplexity and return a concise answer with citation. Use this, right? This is a very important part of the description prompt. Use this for up-to-date or external knowledge. And then, I don't like this part. I don't want it to have a model. I don't want it to define model. Just use a default model. Okay, so this query is a required one. So in our env example, we now just have Perplexity stuff here. So we'll go on our env, we'll paste in the Perplexity stuff, grab our env key, paste it in the Perplexity env key. And now, moment of truth, and I assume this should have been a one shot. So I restart our app and then run it. Tell me news about the UAP UAP missile shot that happened recently. Oh, we failed to get a response. Why did we fail to get a response in this one? Oh, same issue. See, okay, so another like quick pause here, quick side note. See, I just got the exact same issue that we already solved. And if you keep getting like similar issues like this, or like we already did solve this in that sense. Actually, oh, I fucked it up. Wait, hold on. Let me prompt that once. Tell me news about the UAP missile shot in Congress. And prompt it once. I think I messed it up because I hit a hotkey. What I was going to say is that if you keep running into the same cursor agent mistakes that you already solved, just make it a cursor rules. It'll never deal with that again. That was just the side note. But I assume this is running. Bro, the UAP was wild to watch, bro. It was wild to watch. So look at this. Did we even get a response? Let's see. So check this out. This is sick. So just boom, one prompt. We I don't think it's CGI. Bro, we've had aliens we've had aliens for so long. They walk among us, gang. You just gotta know. It's like instinctual at this point. But example, I wanted to know news about the recent UAP missile shot that just happened, which is crazy, by the way. And our AI response, but I don't think it prompted correctly. I don't know why it doesn't have the Hellfire missile shot that happened today. And let's see what it responds with this. So this loop is working. Anyways, it does take a minute to get a Perplexity response. But point being, here we go. A video released to the U.S. Congress shows a Hellfire missile fired by U.S. MQ-9 Reaper drone striking an unidentified aerial phenomenon, UAP, described as a glowing orb off the coast of Yemen. Remarkably, the missile apparently bounced off without damaging the object. The footage, dated October 30, 2024, was presented during a House Oversight Subcommittee hearing on UAPs and has been covered by multiple authoritative media outlets. The key details include the video unveiled by Congressman Eric Brosen. Anyways, point being, first off, the UAP thing, crazy. Magic Man, I don't know if you've seen that, crazy. But through the loop that we have just discovered here, I could probably take the user response right here. Or I could get rid of the user response just because we have a tool response now that is working. Or probably customize this to be something else. But kind of, yeah, that was practically a one shot of getting our AI agent access. Like right now, so the interface right now of our AI agent is simply just a terminal tool, right? But through the code and through the backend stuff that we have, our terminal tool, we could give it access to any calculators. It knows when to use a calculator, right? Because keep this in mind that even though we have internet search, we also still have access to the calculator tool. Like you could give it multiple tools and they could run. Usually you could give it multiple tools and it could like combine them together. But, so I'm gonna say something, you know how it says MK9 drone here, right? I could be funny and be like, what is 1000 multiplied by the digit from the MK Reaper? And it should give me 1000 times 9. Yeah. So right here, let me move myself again. But right here, I kind of prompted, what's 1000 multiplied by the digit of the MQ Reaper? 1000 multiplied by the digit of the MQ Reaper is 9000. And it knows because of context history recently, the numbers from natural, unstructured language to grab. And you can see right here, like it just multiplies and it just knows. So you guys kind of want to go through. Someone on YouTube said that he's doing his usual programming work he does for YouTube Live while he's lonely. He's looking at another monitor. Bro, I have a class of students in my Discord I'm talking to. I'm not lonely. Guys, they think I'm schizophrenic on YouTube. I think I'm not talking to anybody. I'm talking to my class. Anyways, like, first off, you guys should join the class. Link is in my bio. I'll also like create a link right now. I'm not schizo. I'm actually teaching students actively in a class on Discord right now. Anyways, can I paste this in? Yeah, join up the Discord. That's hilarious. Anyways, so that was the base. I'm gonna push this to GitHub and be like git commit added perplexity MCP tool. Oops, git commit added perplexity MCP tool. Git push. Let's get rid of this test.ts tool. But so that covers class today. We have walked through how to set up OpenRouter. We have walked through how to set up OpenPipe with OpenRouter and how to debug with OpenPipe. We talked through how function calling works and how AI agents could just naturally call parameters of functions you define, how to create the functions and execute the functionality in code and feed that context back into an AI agent. We also were able to do this without touching a single line of code. So we essentially vibe coded this, but we vibe coded this with concepts and a foundational understanding, which allowed our Codex agent to work successfully. Now, in terms of the code from GitHub, I'm going to share it with you guys right here, just so you guys could look and play with like a simple terminal UI just from everything we learned today. So I'll paste this in chat. But that was it for like basic core concept of this is how LLMs could use function calls to execute reliable functionality in apps. So I hope watching this class, you understand completely how AI agent frameworks work and how AI agent apps work. Because it all revolves around that same core system design of AI agent, LLM, system prompt. It has access to tools, and then you could execute the tools, and then you could run that up. That is literally the core foundation. What I showed you guys is the core foundation of every single AI app in existence. And that is going to be the core foundation for every single AI app in existence moving forward. That base schema, never going to change. Literally, that's never going to change. This video is timeless. So you go through, I highly recommend playing with it and trying out different AI agents and giving them different tools yourself. Don't try to use your own MCP. Don't try to just like make MCPs. A lot of people make useless MCPs. Like, use functions yourself, use tools yourself. Next class, we could get into actually explaining how we could start getting into agent loops and creating agent loops and more complicated AI agent design. But that was the base. That was a very strong foundation. Before I end class, does anybody have any questions? Also, did that make sense? Someone said really great way of explaining. I'm going to assume yes. I'm going to take this and just open this up for any questions we got. Is it your birthday today? It is my birthday today. No, this was a birthday stream. I just saw the little notification. Go to stream. I'm glad to have joined today. Thanks, gang. I appreciate it. I'm big. I'm 23 years old today, so I'm not UNC status yet. Well, I appreciate it. I appreciate it, y'all. Thank you so much. I really feel the love. 23 AM master. Yeah, couldn't skip the birthday stream. Small potato. We need to get you a Latina with priors. I already had a Latina ex. I'm over the whole Latina thing. I got a baddie white girl. But so okay. Small potato said, "Boo, I'm curious. What did you do before getting into vibe coding?" I did NFT trading and crypto trading, specifically through bots. So no, you guys. I don't know if you guys were in ETH, but if you remember how Ethereum gas wars worked, I figured out a strategy to hit mints before the gas war went off. So I got really cheap, reliable mints before the gas war went off, and I was like the first person to accidentally discover that. And I just kind of kept it. Before I got into NFTs, when COVID hit, I was doing a lot of reselling, so sneaker reselling, card reselling, console reselling, Amazon, e-commerce, eBay. I was doing all that. So I did all of that before I got into coding. And then in high school, I like got a side hustle like selling Shopify websites to people. I don't really know. But I didn't really get into vibe coding until I started a project 2 years ago. So this is all like new knowledge. But it's like, again, like I don't want you guys, like this is very, very important. Do not feel like you are late to like, bro, trust me. Until this tech did not exist 2 years ago. This is brand new tech. No one knows anything. And we like there's too much demand and not lack of talent. Mark Zuckerberg would not be paying $300 million bonuses if this skill was not rare and required. Just keep that in mind. But thank you guys for the birthday wishes. I really appreciate it. I feel the love. And yeah, next Wednesday we'll get into, I guess, designing more sophisticated AI agent loops. Would this be a basic intro video? Definitely not. I mean, this is a good intro video for understanding like AI agent functionality in general. So it's like this is a good basic intro for AI agent functionality in terms of how functions work. I don't have a prerequisite playlist in terms of like how I set everything up. You could watch, I have this codex video on how I set up my codex, which is a good prerequisite if you want to get into like, because you saw how easy that codex agent was able to make like my reliable code. It was like butter, bro. It was just like we just ripped. So you could try this. This is like a good video to just watch and understand like architecture and all that. Well, this video was a good in-depth of like actually getting into like the function calling. You should build a trading bot on stream. That would be fun. But okay. In terms of that was stream. I will see you guys. Please feel free to hit me up in chat anytime you guys got questions. Yeah, for sure. Hit me up. But okay. Bye, guys. Thanks for coming.